All right, today's lesson is 1-3. Our main topic is structure. So let's talk about how to do the code setup, like just to be more formal about it. We've kind of been lackadaisical. We've been lazy in terms of how we've been setting up our code. Generally, the code should have main parts. So part number one, I usually call these the parameters, or if you don't like that word, you should be thinking variables. So that means when we open up OpenSCAD for our project today, so if I go to OpenSCAD, the first thing that I'm going to start is by just commenting out a section called variables. So let's make this slightly smaller. Zoom, zoom. Exactly, yeah. So I can just do a giant comment. If you do a bunch of these, it looks cool, I guess. And then you can do, I don't know, anything that makes your comment looks cool. Sure, that looks really cool. And I can call this section parameters. And then parameters are the variables, so I can say maybe height is equal to 70, and then I could say diameter is equal to 50, stuff like that. So these are where all the variables are stored, right, Gunnar? That's really important, thank you. All right, next section. This is usually where you're going to render things. Render. And I guess technically it's the preview section, but it's where things are actually called into like being. And that seems kind of weird for us because like whenever we type in cube, it's automatically rendered. Today, that's not going to be the case anymore. And that's because, we'll talk about that later, but we're going to be doing things called modules. And just to give you a heads up, I can do something like module. I can call something like, I'm going to call it Colby. And Colby is just going to be a blank function. And Colby, you are a cube. You're a cube that's 10 by 40 by 100. Notice that if I render this, what am I, semicolon, haha. If I render this, there's no cube because I didn't actually render Colby. So I need another section right here for something like, I'll just call this render. And in order to render Colby, I need to call Colby, like that. Now I've called Colby, so Colby appears, and there he is.
Wow, Colby.
I didn't know you were so slim, Colby. Yeah, so rendering things and actually doing the code for things are two separate categories, right, James? You're looking at your lap, so I'm just assuming that you're hopefully paying attention. All right, and then your third category and our final categories are code. Code slash modules. I'm going to try to get all of us to only do modules for the rest of the class just to be organized. And if you don't like the word modules, I can use a different word over here. It's typically called...
What if you don't like using modules?
That's too bad. I'm going to force you to do it. And once we do your own project, if I make it a condition that you have to use modules, you have to use modules. If the project is open, then you don't have to use modules. But I want to get very formal about doing code because it's a good skill to have. Especially if you plan on doing any sort of code in your later career. If you're formal about it now, it'll be easier to be formal about it later. Does anyone want to take a guess? What's another word for modules? I don't know if starts with an, say again?
Sections?
No. Is there a quiet raised hand? Another guess? Go for Gunner.
Modular spaces?
No, that sounds even harder than modules. Functions.
That's what I said.
I must have misheard you. Functions. So a function will take in something and it will display something, or it will do something. Cool, so let's now talk about modules. And modules, again, are in the cheat sheet. If you ever forget anything, everything is always in the cheat sheet. Let's come over here to Google, switching here, command down. So if I come to, oh, I actually have it open already. So if I go to the cheat sheet, notice that over here you have modules, and technically functions are different than modules because they do things like mod functions or something like that. But modules You basically type in module and then you get to name your module. I named my module back over here, I named it Colby. So if I want to change this module's name to @0, then if I render this, nothing will happen because there's no module called Colby. It's saying unknown module Colby. If I come back up here and change this to @0, and now there's @0. Seems pretty straightforward. You do the code down here and then you call the code up here, which is really valuable because if I need to do a bunch of things over and over, like a function within a function within a function, it gets confusing really fast. So just being able to call code up here versus writing the code down here. All right, so yeah, so let's write down our code right here. So it's going to be module. It does need to be lowercase. You always need to have module, and then you do the name of the module. So I'm going to write down name, and then right here I'm going to write down parameter. Parameters. And we'll see an example in a sec, but that's the general way that you set up a module. And then you start your curly brace. That's a bad curly brace. Let me see if I can do a better one. There's a better one. Curly brace, and then you end the curly brace, and then you do code here. So it's really important that you guys know that whenever I write the module, I actually need to call the module to render the module. So far, so good. All right, let's see an example.
No, you're getting a lot of XP today.
Am I? Oh, thanks.
I said I have given you XP 6 times.
Oh, wow, really? Thank you.
Yeah.
What for exactly?
What?
Why did I get the XP? How can I?
Awesome teacher.
Okay. So an example. Let's think of a module. Okay, so I want something that takes the difference of something else. So let's do like a potted plant. So I want this potted plant to have a cylinder on the outside and a square on the inside. So the square hole. So if I were to do a little sketch first, this is what I want to have. I want to have something with a wide top. It comes down to a skinnier bottom. And then I want a square hole kind of right here. And of course, if Mr. Sindel could draw, I could maybe add some perspective here. And then this comes down like this. So for our future projects, we're going to try to always start with a sketch. This comes down like that. Sketch, sketch. Good enough. So that's the type of shape that I want. I don't know. For some reason, our client wants to have a potted plant that looks like that. So how are we going to do that? Technically, we could do this all as one module. So we're going to do that. So let's write out the actual code that we're going to write. So we're going to say module. And now we need to name this thing. What should we name it?
Full Metal Jacket.
That's kind of a long name, but sure, we'll write Full Metal Jacket.
Billy.
Billy? Okay, module Billy. And I believe modules can have capital letters in them. I'm curious, can I try that out right now? Let's change this to capital A, capital A. Does it like us still? Yeah, so you can have capital letters. If we want to call this capital Billy, we're allowed to do that. Billy. Oh boy, people are emailing me all nonstop. So Billy. Nope, sorry, go away. So what Billy is going to take in is he's going to take in, we get to call the variable whatever we want. So I'm going to say height. We want to know what the height is, so I'm going to say height. And do you want this height to have a default value? Remember, normal parameters have default values. Centers maybe defaultly set to left or center set to false. Do we want height to have a default value? We don't have to. But it makes it so that the function won't ever mess up if you forget to pass in the height. Let's do a default value, yeah? Let's say our default value is 10. So what I just did right here, I set the default value to 10. And I'm just going to do one of those, but you could have multiple parameters. I could do comma, something, something, comma, something, something, and end the parenthesis. But we're only going to do one parameter, so I'm going to end the parenthesis and I'm going to start the curly brace. And I know that I'm going to end the curly brace. I might as well do that down here. All right, so we essentially have three things that I see. I see some sort of cylinder, I see some sort of cube, and then a difference between those two. So I think we can do this in 4 lines of code. Do you think you guys are skilled enough to do this on your own, or do you want to work with me just for a little bit? All right, let's do a vote. 1 is work on your own, 2 is work with me for a little bit, and then work on your own eventually. 2 is work with me, 1 is work by yourself. It's kind of divided. We'll work with me for a sec. Okay, so first we're going to do a cylinder. This cylinder will take, hopefully you have notes from yesterday. If you don't have your notes from yesterday, can you pull those out? If you have them sorted away. Unless you understand cylinders perfectly, what's the first parameter for a cylinder?
Height.
It is indeed height. And since we are passing height in as a parameter in our module, we also need to use this variable name. This is a variable. This variable's name is height. You can just take all of your notes and then put them all back later. So the first parameter for a cylinder is height, and since we have a variable for height, let's pass that variable into this new parameter. That means whenever we're changing our module, this will automatically update the cylinder on the inside of the module also. So height. What's the next parameter for cylinder? Cohen.
Yes.
Which radius? Can it just be a normal radius, or is it radius 1 or radius 2? And it's your choice, right? Yeah. So it can be radius 1. So Gunnar, you're giving him 50 XP. Yeah, so it's going to be radius. And since we don't have a parameter for radius, let's just give it a value. How big does that look? Someone just shout out a number. How big does radius 1 down here look? This radius? Okay, we're going to say 2. Quiet raised hand. What's the next parameter in cylinder? Julian. So if we did radius, so we're calling this guy radius 1, then we're also going to have another radius over here. Yes. Go ahead and give Julian 50 XP. It's going to be radius 2. And Julian, how big does that look? If this is 2 right here, how big is this radius right here? Probably at least double, I would say. So at least double. Okay, we can go with 4, yeah. Let's go with 4. Yep, XP. And let's go ahead and end the cylinder with a semicolon. Okay. Now we need a cube, but that cube isn't going to be, if we did a normal cube, that cube would be down here, so we know that we're going to need to translate the cube. So let's go ahead and set up that code. We're going to do a translate. Oh, we do need a difference up here, don't we? We'll do that at the very end, because the difference is 1 line of code. We're going to translate. We don't know what our numbers are yet, but we know that we need a square brace, no semicolon, and we know that we need a cube. Yeah, I said 4 lines of code, and we've only done 3 lines right now. So that 4th line will be the difference. All right, well, you can do an arrow up here to say the trend or the difference goes right there. All the stuff, since I have technology, I will move you down. I forgot the parenthesis right there. So up here you would normally have a difference. I can't spell difference. Difference, and then something like that. So it does need a curly brace, which means we need an additional curly brace down here. If there's 2 curly braces to start, there should be 2 curly braces to end. And it doesn't really matter where you put them. If you're being more pragmatic about your code, then you could put them in the correct order. For example, if I move all of this stuff off to the side and grab all of this stuff and move it up so I have more room, then I would much rather put one of these curly braces, do this one right there and this one right there. That would be formal code, because this difference right here, this curly brace, and this curly brace match up because this curly brace is directly underneath difference. Okay, and I think you guys probably have the rest. Go ahead and figure out what to code for the translate. I will give you a hint. Something for this Z. So you have 3 conditions. You have X, then Y, then Z. This Z will need to take in a value of height somehow. So I want you guys to try to figure out what numbers to go in here for the cube, what numbers to go for the translate. You basically just need those 6 numbers, and we'll see what you get. So the tricky bit is this Z value and this Z value, they both need to be based off of this parameter called height, this variable height. So you might need to extend these a little bit. You might need to make them go farther out, like to the right. This stuff might be pulled out here to the right. Yeah, but that Z value and this Z value will have to be a little bit, you'll have to be careful. All right, so I'm going to be walking around helping you guys get these numbers in here, and then we'll type it in and see if it works. All right, so I guess we can get rid of these parameters up here since that was an example. But there is the code that we have thus far. If I render this, nothing is there. So let's go ahead and just kind of choose some random values. If I was looking back here, I can give some dimensions. If this dimension right here, up here was 4, what does it look like this dimension is right here for the X direction of the cube? Someone shout out a number.
4.
I could see it being 4, yeah. Okay, what about the height of the cube?
2. No, 4.
The height of the cube, I don't think it's the same dimension. I would say either 2 or 3. 2. Okay, what about the depth of the cube, the y dimension of the cube?
4.
4? I don't.
Like 3.
I would say 3 too as well. Okay, so let's go ahead and put those numbers in for our cube. So our cube is going to be the x is 4, so 4, 3, 2. So 4, 3, 2. Again, that won't be showing. I'm going to go ahead and render this so we can see what's going on. So I'm going to call Billy. And zoom to size. So there's Billy so far. He's pretty small. And we don't even see where that cube is. Why are we not seeing that cube? Oh, that's because it's all the way down there. Oh, because we're taking the difference of him. So if I do a percent sign here, we can actually see the cube that we're subtracting. All right, so there's that cube, and now we need to translate it. So we need to translate it in this negative x direction. So if it goes negative x direction, it's going to come towards this way. How much in the negative x direction should we translate to center it?
Just 1.
So the x dimension is 4. We need to translate it half of 4, right? In the negative x direction. So negative 2, right? Negative 2. It always has to be half of that cube. And then we need to do half of that y in the negative direction. So what should be the next number with a quiet raised hand? Quiet raised hand. What is the next dimension for our translate? Colby.
1.
Close. Negative 1 will go right there. Let me actually make it.
So is it B for answering that?
So negative 1 doesn't quite center it in the y direction. It looks like it still needs to come down a little bit more. I need to take half of the y dimension for the cube. Go for it again, Colby. 1.5. If I do that and I look at the cube, now it's perfectly centered. Yes, so that's correct. Everyone write it down. Our translate is -2, -1.5. And then this is the tricky bit, the height. So if I show the cylinder again, and the cube is underneath there, so let's do a percent for the cube so we can actually see the cube. The cube is right in the center now. I need to go up. Well, I know that if I go up height, so if I do the variable height, that won't work because that's too tall. I need to go down a little bit. But how much do I need to go down?
7. Try 7.
No, it's a number that we've used in cube.
Oh, try.
One of these numbers that we've already used.
Try 2.
Cohen. Where did 3 come from? 3 is the y dimension, right?
Yeah.
2 is the z dimension, and z is going up and down, right? So I should do height something 2. Go for it, Cohen. It's adding or subtracting. Yep, so -2. If I do that, now my cube is perfectly right there. We're going to add some like 0.01 just to make it so I can see it. And if I get rid of that percent sign, we have our client's vase or whatever they're doing. And of course I can make it a little bit more round by coming up here to a parameter and saying money FN is equal to 100. Now it's nice and round. Semicolon would be nice. And now I have the vase that we originally pictured over here. It's really important that we know that this does not show up if Billy is not being called. I have a module called Billy right here, and if I actually call Billy, by typing in Billy with the parentheses right here, I actually render Billy. The cool thing about our module Billy now is if I do Billy and I do 50, Billy is really tall. I can change Billy to be whatever I want. I could do Billy and I could do it like 7. If I render that and zoom to size, Billy now has a height of 7. I can change that to 7D, render that, and Billy's nice and tall again because we've passed in this parameter called height. If I want more parameters in that module, I just do comma and I keep adding them. You can make your own modules now. Are there any questions about what we just did? Modules. No? Okay, let's talk about next, what should we do? Let's do loops. So our next section here is going to be titled, I feel like if I go too fast, you guys are not going to get modules very well because it's kind of an important topic. Let's play for 5 minutes. I want you to make at least one module on OpenSCAD. So we're only in OpenSCAD, we're not playing games. I want you to make your own module that does something cool, that uses everything that we've talked about. So it has a parameter here, it has some cool thing that happens, and then you actually render it. So you definitely need to have these 3 sections, and you can make the code look as cool as you want it to be. I want you to make your own module and play around with it. All right, we're back after playing with some modules, and now we're going to talk about children.
What? Huh?
You didn't even realize it was a sex ed class. All right, so children is a specific function, and you use it within modules. And again, everything that I'm getting right now comes from the cheat sheet. So where are children? Command F, children, down here.
That scared me, Mrs. No, not gonna lie.
Special variables, other, yeah, so children right here.
HP for Mrs.
So say you want to apply your module to another shape or another module. How do you do a module of a module? The answer is children. And children has a very specific meaning whenever you're talking about code. Children means anything underneath that. Usually you talk about nodes and stuff like that. I'm not going to get too much into the nitty-gritties, but say I want to do something where I want a module that will take in a shape and then cut a hole out of it. So we're going to say module, and I'm going to call this hole. What this module will do is it will take in whatever shape you give it and it will make the same hole over and over. That's all this module will do. So module hole, and it's not going to take any parameters, and then you're going to start your curly brace. We're going to end our curly brace down here. I don't know how much we're going to write here. It shouldn't be too much. But let's say I'm going to take a shape, and I don't know what shape that is, so I'm going to say children. Whatever shape that you give me, so that's going to be a variable called children. So children. This variable, I'll do a little comment, and I can make it a slightly different color too. This variable right here takes in a shape. This is a variable saying, hey, whatever shape you give me, I'm going to use that shape, and I'm going to do the following thing to it. And dang it, I forgot again that I'm going to be doing a difference. Sorry, put an arrow up here. We're doing a difference between the children and something else. I apologize. I keep reading that we're writing that. So above this line, we have children, we have children and then difference. This difference is just going to be parenthesis, and then we're going to do some things to it. We all know how difference works. Parenthesis, curly brace. If we have 2 curly braces to start, we definitely need 2 curly braces to end. We'll make sure to do those at the very end. What's it? Yeah. All right, so we're going to do children, and then we're going to do a translation. Let's just do something simple. I'm not even going to translate. I'm just going to do a cube. And that cube will always be the same size over and over again. This cube is going to be 5 by 3 by 5, for example. And I think, do we need a semicolon here? I forget if you need a semicolon for children or not. And then I'm going to end my difference right here. And this is something that I've started to get into the habit of. You don't need to do it, but if you are getting confused on your code, I will make sure that you go back and do this. So this curly brace, what did this just do? Which one did it end? Did it end the difference or did it end the module? Quiet raise hand, James? Difference, yes. So thank you, Gunnar. So what I'm going to do here is I'm going to put a comment. I'm going to say that that ends the difference. So I put a comment after that curly brace so I know that I just ended the difference, and now I say, oh, well, I didn't end the module, so I'm going to come down here and do another curly brace and do a comment, so double /, and I'm going to say end module. Now it's very clear by looking at my codes, oh, that's why you have those curly braces there, because you have to, if you started a curly brace, you need to end the curly brace. Okay, so let's see how this actually plays out in the code. Let's see how fast Mr. Sindel can type here. Not that fast. I'm going to call this module whole. I'm going to end that curly brace down there. I'm going to do a difference. And I'm going to end that curly brace right there. So this is going to be end difference. This is going to be end module. Okay, in here I'm going to take in the children. So children. I don't think I need the semicolon. We'll see if I need that. And then I'm going to just do a cube. What I do a cube size 5 through 5. So 5, 3, 5. Do need a semicolon there. And let's do. So if I run this whole, nothing will happen. I can do this whole on something else. Let's say I'm going to apply this whole to something else. Let's do it on a cylinder. And then I'm going to end the semicolon there. The cylinder is going to have a height of, I don't know, 50. It's going to have a diameter of, I don't know, 40. Sounds good. So if I actually run this now, is it happening? Cube 5 through 5. I guess that cube is really small. Do I need a semicolon here? Is that why it's not liking me? Yep, that's right. Okay, so go back to our notes. It does need a semicolon. My bad. This children needs a semicolon. Let's grab all of you, move you to the right. You do need a semicolon right here for children, because that is an object. I guess that makes sense logically. Children is an object, therefore it should have a semicolon. So you can see here, if I zoom to size, and I guess I'll zoom in a little bit more, that you see that I am taking that original shape and I'm cutting a hole in it. So I'm cutting a hole in that cylinder. And I can change this cylinder, and no matter what I do, I'm always going to have a hole right there. So if I change this to a cube, I'm just going to do a cube of size, I don't know, 10 by 10 by 10. I will always have a hole right there because this module will cut a hole from the children, which is the cube, and then it'll cut that cube inside that cube. Are we okay with what children does? Roughly, give me a fist of 5. 5 is like, I understand children super well, and 1 is, I don't know what's going on. Okay, those scores are actually too high. I give myself a 4. I still don't understand children very well. Like, what if you want to do 2 different children? Well, how would that work? I don't know. So I give myself a 4. If you're giving yourself a 4 also, that's because you have self-confidence in yourself more than I do, which is really good, but it's probably misplaced. All right, so that's children. Let's talk about our next function, which is, I totally forgot what I was doing. Oh yeah, I need to talk about unions and stuff. Unions and intersections. So let's come back here to our notes. Let's go to a new slide. Let's talk about union. So obviously, this is a sex ed class. First, you have to do union, and then the children come after that. No, okay, bad joke. Union. This will combine things. So union is the equivalent. Union is the equivalent of gluing things together, whereas difference is the equivalent of cutting things out. So difference is making a whole. Union is gluing things together. So think of this, and I'll put this in quotes because it's totally not specific enough, but this is gluing things. Gluing things together. And you might be thinking to yourself, Mr. Sindel, why would I ever need to glue things together? Because if I just go back to OpenSCAD and I just do, let's get rid of all this stuff. I'm just going to render things immediately. If I do a cube, that's, I don't know, a 10 by 10 by 10 cube, and I do a translate of another cube, I'm going to translate this up by, I don't know, 0, 0. We'll do 8, and then I do maybe some weird cylinder that has a height of, I don't know, 5, 50, 5, I don't know. And then let's go 10 by 20. Oh, semicolons are always nice, right? I don't know, it's just some random shape. I needed a random shape. The question that you should be asking right now is, well, aren't those glued together right now?
Yeah, aren't they glued together?
Because if I export that, yes, they are glued together. That will print out as whatever this weird shape that I made was. Yes, that works.
What's it called? What's it called? Notes. Difference in.
Oh, I don't need a semicolon there. That's why that's not working.
What happens if you do the difference on it?
If I do a difference, then it will cut a hole in the top of the.
Like with a hole in it.
Well, for now, I think you already know what's going to happen. You can play with that on your own. I want to know how to cut a hole in both of these at the same time. That's where union comes in. If I want to cut a hole in both of them at the same time, I need to union them and then do a difference of that union in something else. So you don't use union very often. You usually only do it when you want to cut holes in multiple objects at the same time.
So you're gluing them together to cut them apart more efficiently.
Yes.
Put stars in front of all the shit though.
And that'll just make a sphere.
Exactly.
So let's write down why you would ever want to use this. How are we going to say this, Colby? To cut things apart or cut holes to difference things more efficiently?
Glue them together to cut them apart more efficiently.
To cut apart more efficiently. I like it. And I don't really need to say anything aside from how to actually do the code. The code looks like this. Union. You do your parentheses, you do your curly brace, you do the end of the curly brace. Object 1, object 2, object 3, object 4. However many things you want to glue that goes inside of the union. It's very similar to difference where you don't have any parameters. You don't have anything inside those parentheses. You just glue it. It says, hey, glue these things together. Done. They are now glued together. Let's see why I would want to do this with code. And this is the part where you finish writing down how to use a union and you just get a look at the example. So everyone has this written down. James is finishing it up. And as he's finishing it up, waiting for James. And okay, so why would I ever want to do this? Well, let's say I want to cut a cylinder hole through both of those. So what if I wanted to come up here and say, okay, all of that is one line of, this is one object, theoretically, but it's not glued together. So what happens if I do a difference? And I'm going to end that difference down here. What if I want to take all of that stuff and I want to just subtract some cylinder that's really small? So like a cylinder that is really tall, so we'll do like 20, but it's really small radius, so like 2 and we'll say D is equal to 2. So really, really small. What would that look like? Oh, that's weird. That top cylinder went away. That's the problem. This cylinder right here, if I put a percent in front of this, that cylinder right there went away because the way that difference works is it says, hey, this first shape, that's the only main shape. Everything else is a hole. This thing is a hole. This thing is a hole. So in order to make both of these together and not be treated as a whole, I need to first union them. So I'm going to come down here and I'm going to say union of those things right here. And I can tab this stuff over. So let's get this looking a little bit better. Union, this stuff, put a tab there. So now when I run this, now I have that original shape, which is what I needed to do with the union, and I'm cutting that thin hole through both of the shapes. You can see if I zoom in right here, it is indeed cutting through the square as well. So union is to cut a hole through multiple objects at the same time. That's it. I'm not going to talk about it anymore. You're probably never going to use it. Well, I shouldn't say never. You're very rarely going to use it. And the next thing I want to talk about is intersection, which is really cool. It will save you a lot of time. It's a little trick. So let's come down here to our next slide. Let's talk about union. No, not union. What did I just say? Intersect. And it's called intersection. Whoa, come on, computer. Intersection. Intersection is really, really cool if you know what you're doing. We're starting to finally get into really cool functions.
You said yesterday.
I said that we would get to it tomorrow, like the really, really cool functions, and that's not a lie. Thursday we get into some really cool things like Minkowski. What is it? We do Minkowski. What else are we doing tomorrow? Tomorrow we're also doing a whole, which will be fun. We will be doing a, what is it called? We'll be doing polygons. We'll be doing polyhedron. Those are really, really fun things. You can do rotate extrude. I don't think we'll be able to talk about it tomorrow because tomorrow's going to be so advanced. If we have time, we'll do it on Friday because it's really good for applications in calculus because in calculus you have to do these 3D modeling things and that's the main calculus function that you use. Just for us, it's not super valuable yet.
I just want to
Have you ever made a game on OpenSCAD?
A game? You can't really make a game on OpenSCAD unless you're making like a maze that you print out. That would be fun. Or if you print out a puzzle, I guess that's kind of a game. Like this guy, right? That's kind of a game, right? No.
I want to make a
I was solved it on the last day of.
All right, intersection. What does it do? Only, and I'm going to put this in quotes because it's not superficial, only the overlap shows. I can't spell shows. There we go. Only the overlap shows, and it's the same type of code setup. You type in intersection, and then you do parenthesis, then you start your curly brace, and then you end your curly brace, and then if we're being formal about it, we'll do a comment, and we'll say end intersection. And this is really cool. If you ever see cool looking rocks in a 3D print, I almost guarantee that they did it with an intersection, and if it looks really cool, they did an intersection with a Minkowski over that. But we can't talk about Minkowski yet. That's tomorrow. But generally, the intersection is how to make really cool looking rocks. Mike Wazowski? No. All right, so let's come back up here. Let's get rid of all this stuff. What I'm going to do now, let's render this. Nothing is there. Reset the camera. So if I'm going to render this, let's do intersection of all of the following things and intersection. All right, so let's do a cube. And I'm going to make that cube, I don't know, we'll do 10. And then I'm going to, let's actually see what that looks like so far. Always forgetting this semicolon, the periods of my sentence. All right, so cube isn't that interesting by itself. But if I do a rotate of a cube, don't forget your semicolon, there we go, cube, and I'm just going to do another cube of size 10 again. So it's, if I just don't do any square brackets for cube, that's just saying 10 by 10 by 10. It's a quick way of actually making a real cube, not a rectangular prism. And I'm going to rotate this one kind of randomly. So I'm going to go, I don't know, 10 there, 50 there, negative 30 there. If I do that, that went too far. I think I did too much of a rotate. What does that actual shape look like? We will not rotate it that much. We'll make this maybe 10 as well. Yeah, okay. Let's go ahead and see what that looks like. This is that intersection. Can I zoom in here? It's a weird shape, right? If you do an intersection with 3 cubes, it will be even weirder. So what's actually happening here? If I put percents in front of these, you can see what's happening. Can I do percents in front of them, both of them? I have these 2 cubes. Wherever they both overlap, that is what is going to print out. So if I get rid of both of these, that intersection, so ready? Boom! That intersection right there is what prints out. It's a really cool way of it's really tricky. It's a cool way to do tricky things.
So what if you just spam a bunch of random stuff and say, I did this, this looks
If you do
cool."
too many things, there might be no intersection and nothing will print out. So as long as you make sure that there is an actual overlap, then yeah, it'll look really, really cool.
So you can just make a bunch of random garbage.
Yeah, and
This is modern art.
I mean, right, yeah. So their intersection, if you go online, is really cool. Like they did an intersection of a cube with a cylinder, or a cylinder with a cylinder. Their intersections look pretty cool. Is that the only one that they give us? Okay.
The Mona Lisa and abstract art piece.
So they intersected a cylinder with a cylinder. Cool. So that is intersection. It is a really good way of doing really advanced things. What else did I have for us? Trying to think. We did children. We did intersection. Let's come back to the cheat sheet here. If I go back. No.
I'm asking
Oh yeah, and then loops. I forgot that we were doing loops. Loops will be the final thing that we're doing today, and then we'll be done with notes. So, loops. Loops. Loop-de-loop. Okay, so I believe there's only a for loop. Let's actually check that. Is Mr. Snell being true? Yes. There's only for loops. There's no while loops. Ooh, I've never done an intersection for before. Okay, but let's do a basic for loop. For. And then you'll usually have some index. Your index variable can be whatever you want. Again, variable names, I could have a variable name called James. I could write James right now. Usually you use single letters because you have to use them quite a bit. So I'm just going to do the variable I. That I is a variable. You always have to have the word for. So maybe you want to underline that. You always have to have for. And then the I, this will go from, it'll step. So I will start here, then it'll go from to the next value. So let me do an example here. For I from 0 to, I don't know, 7. What is happening right here is it's saying, and I do need parentheses here, for this thing that's happening, I is going to start at 0. Let's pretend that Mr. Sandell is I. I'm lowercase I. I'm that variable. I now contain 0. After I finish doing whatever I'm doing, now I'm going to contain 1. Now I'm going to contain 2, then 3, then 4, then 5, then 6, then 7, then I'm done. So it will do things 8 times.
Well, is that how I made that loop for that spider looking thing?
I never saw the spider looking
I
thing.
did.
The thing that you were just showing me?
Yeah, the thing
That did not have a loop.
When I messed up the cup.
That was not a loop, no. All right, so this is saying I is going to iterate through these values from 0 to 7. And you can actually test this out. So let's test this out right now, and we'll say, so you do need a curly brace, and then end the curly brace. We'll say this is going to end the for loop, and the for loop.
2 for loops.
You can do a for loop within a for loop, and that's how you make an array of something. Yeah, so if you ever do a for loop, you can't have the same variable. So if you want a for loop within a for loop, your next for loop, for example, would be for j is equal to blah, 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 blah. So just make sure that you're changing your letter. Okay, so I'm in here. I'm going to do something really, really simple. I'm going to test it out. Does anyone remember how to print out things to the console with a quiet raised hand? How do you print out things with a quiet raised hand, Colby? Quiet raised hand, Gunner, yes.
Put it on that one thing and then that. So you save it.
What?
Not quite. You want to use Mana Shield, or you want to just take it?
I'll take it. Someone heal me, please.
Colby, yes, acquire his hand.
Echo.
Echo. Echo will print things out to the console. So we're going to put an Echo right here. Echo I. Let's see what happens when we do this. What should happen is it should iterate through all of those numbers. So if I'm going to come over back here, let's get rid of all this stuff. So I'm going to do a for loop. 4. And then I'm going to say I is equal to 0 to 7. It's going to do the following things, and this is going to end the for loop. So in here I'm just going to do echo I, semicolon. If I run that, look at this. Echo 0, echo 1, echo 2, echo 3, echo 4, echo 5, echo 6, echo 7. So there are a total of 8 values that it just went through. 1, 2, 3, 4, 5, 6, 7, and 0. So a total of 8 values. Yeah?
Yeah.
All right. So let's actually utilize this a little bit differently. And this is stuff that you have the option of taking notes on. And it's kind of cool if you want to be able to do things. So I'm going to now have some sort of cube. And this cube is going to be centered. So I'm going to do a cube of 10, and it's going to be centered. So true. So if I run this, nothing is happening. It's a normal cube. Let's go ahead and reset the camera here. This is just a normal cube. But I also want to rotate this cube fractionally. So I'm going to rotate this. So rotate this cube by something that has I in it. Remember, I contains 0, then I contains 1, then I contains 2, etc., etc. So I'm going to rotate this around the z-axis by, I don't know, I. So you can do I times 3, I times 4, whatever you want to do. So I'm going to do 0, 0, I times 3. Let's see what happens. If I rotate this cube, I get this shape. Check that out.
Wow.
If I did I times 10, it'll rotate it even more. Get like a star shape.
It's a gear.
Times 11, boom. Looks really cool.
It's a gear.
What if I also rotate it by this direction by I?
What?
Because now I'm rotating around the y-axis by I. Let's do I times 2, and I can make it even more apparent. You can see each of those individual cubes.
Oh, wow.
What if I did an intersection of all of those?
What?
Bro, you're breaking physics, bro.
That's the biological
This is how the infinity stones were created.
Oh, I think you need the intersection on the inside. Let's go back here. Intersection of all of this stuff. I don't know if that'll work. So that'll. Does that work? No, I don't know how to. How would I get those all to intersect? It's not coming to me right now.
Intersect the cubes. Put it after the rotate.
Think right here.
Yeah.
I don't think that will do anything, but we can always try.
And if it does work,
Then you are a genius. Yeah, that's okay. It's harder than it looks because for loops happen at weird things. Okay, but yeah, so that's how to do for loops. You can rotate text. You can do multiple things at the same time. Once you start getting mathy about it, you say, okay, well, maybe I'm going to change this to n, and then I can set n is equal to 6 up here for a variable, and then I'm going to say, oh, instead of rotating by weird things, I'm going to do like 360 divided by n, and then you start getting more and more mathy about it. 360 divided by n, oh, it's a cube, so 6. Let's make it some weird number, 7. Why is it going? Maybe let's make it 80 divided by n. Why is that happening?
why does one happen?
Well, I totally thought that, oh, is it because I don't have a number there? No. Oh, I know why. Ha ha ha. You always have to multiply by I. If you don't multiply by I, nothing is actually going to be happening. So if I come back here to do 360 divided by n, then it should still have those 6 cubes.
It's like a Reese's.
So if I, yeah, weird things can happen. Anyway, that's loops in a nutshell. And that's essentially all I want to teach you today. All right, let's talk about our project. So on our project, you have to have the following conditions. And I'm going to make this up as I go because I've only thought about this for probably 10 minutes. So our project. We are making a reverse card today.
Hey, that was my idea. Do I get XP for it?
Sure, give yourself 50 XP.
Yeah. Did I get XP for being game warden too?
Did you not give yourself Game Warden XP yet? Then yes. Okay, so we are making a reverse card. So the general idea of the reverse card is it needs to look cool. Let's make the dimensions the exact same dimensions here. I'm going to pause.